What we're going to be doing this week is discussing the basic terms that we're going to be using, as well as motivating some basic concepts that are going to be recurring themes throughout the semester. You should also consider this a trial run for the class. If this is an elective for you, you should know pretty quickly if this is going to be worth learning or not. Also, consider how my particular style is going to work for you. This video and the other videos that we're going to use for this class are intended to supplement and not replace the textbook. I'm not going to go over everything in the chapter. In fact, you're going to notice that I skipped entire sections. This isn't because I think there's no value, but rather because I want to focus on the trickiest or most important parts of the text. In any case, this chapter is pretty short, so please do read it. Now let's talk about data and databases. Data, which mind you is the plural of datum, refer to facts that can be recorded. These facts can be numeric in nature, say your height, your weight, or the number of siblings, the amount of money you spent on takeout in the past month. But any fact that can be recorded doesn't necessarily preclude non-numeric facts. So your name, your hair color, or the names of places that you've ordered takeout from also qualify as data. If something can be objectively measured and recorded, it qualifies as data. Information is data that's been used for some decision-making purpose. These data may be processed in some way, most commonly by taking an average or counting the number of records, but data can be combined and processed in an infinite number of ways. At the same time, a single data point, or datum, when used for decision-making purposes, also qualifies as information. Because the boundaries of these two concepts are fuzzy, in general, most people use these terms interchangeably. Generically, when I refer to data, I'm talking about the raw contents of a database, and information for all other purposes. There's an additional layer that comes into play when we're talking about databases, which is metadata. Metadata is data about data. Normally, this is something that most people don't have to think about. But when we use a database, we're looking at a bunch of data out of context. The database system itself doesn't know or care what these data represent, but the people who are using the database care quite a bit. So while we might have collected some data, we need some way to describe what the data represent, and some format and what kind of format the data are in, and so on. As a concrete example, if we had one point of data, the temperature, and it read 50, how would you dress? 50 degrees Fahrenheit is sweater weather, but 50 degrees Celsius is Phoenix in July hot. For that matter, it could also be 50 degrees Kelvin, but if that were the case, we'd have bigger problems. Let's put this in the context of a toy example. I have 5 students: Amir, Beth, Chow, Deepak, and Eric. They each did homework on chapter 1 through 4. I have one review class session before the midterm, and I want to spend that class session in the most effective way possible. First, let's consider what we had before we do anything to a database. We have 5 people and facts about them, their homework grades. This is data. So let's put this in a table, where each row represents a student and each column represents a fact. This is data, but without metadata. If someone gave this to you without any other context, you'd be confused. So let's add on some metadata. First, the column names, and note that the column names themselves are metadata, and then some more information about the columns that you might expect to see in a database. So now I have data, and I have metadata that describes it. But I have a decision I need to make. What chapter should I focus on for the review? Because this is a simplified example, let's just say that I'm going to focus on the chapter with the lowest average score. In this case, I'll need to apply some process to the data to make it usable for that purpose. Taking the mean is one such process, so let's do that. Note that we don't need to add this to the database, but rather if we do this again, we can just run the same process on the data. So now I have the average homework score, which is information that I'm going to use to make a decision. Let's talk about how databases operate and how we operate on them. This isn't an engineering class, and I don't expect you to know the intricacies of what databases are doing under the hood, but it's still important to know in broad strokes how databases work. The first thing that we're going to point out is when I refer to a database, I'm really referring to a database management system. The database itself is a collection of ones and zeros that are unreadable by humans. For the purposes of this class, and generally speaking in the real world, most people will refer to the combination of the database management system and the database as simply a database. The Database Management System, or DBMS, is responsible for interfacing with the aforementioned collections of ones and zeros. Common database management systems include MySQL, Microsoft SQL Server, MongoDB, CouchDB, others. DBMSs are normally not compatible with one another, so a database created in MySQL wouldn't be able to be read by Microsoft SQL Server. In other words, each DBMS arranges those ones and zeros in their own way. At some point, humans need to interface with these databases. We group these methods into 2 broad buckets. First, we have what's called direct interaction. This is where a person, usually an analyst, interfaces with the database management system directly. One method of direct interaction is using SQL, and not to spoil future parts of the class, but this is what we're going to be doing throughout all of Unit 2. At the same time, databases are in use in nearly every possible facet of computing that you can imagine, and you use them more often than you might think. If you're doom scrolling on Twitter, you are in fact interacting with the database, and you just don't really know it. This is what we refer to as indirect interaction. There's a front-end application, in this case Twitter, which is sending requests to the database and retrieving the data from that database on your behalf. The key difference between direct and indirect interaction depends on the person who has needs that are being served by the database. We call this person the end user. If the end user is writing database queries directly into the DBMS, we call it direct interaction. If the end user is getting data from the database but isn't interacting with the data themselves, we call that indirect interaction. And the front-end application is translating the needs of the end user into database queries.